Alright, this will be a test here. So let's learn about density. Density is purely the amount of particles. So let's talk about a circle here. It's kind of like the amount of particles in one space. So something like this that would have lots of dots compared to, say, material that look like this. See, there's more dots on this side than this side. So this material here is a higher density. So essentially it has greater mass, greater weight per square unit of whatever you want to call it. So for example, you might break this up. That's 1 square millimeter. 1. So this one might have 3 dots per square millimeter compared to this one, which has 1 dot per square millimeter. So that's like kind of saying that this one has 3 times the density of this one, so 3 times the mass of that one. So if this was a block, and this block here was, for example, 0.1 meters, and this one is also 0.1 meters, and let's just say that the diameter of this was, let's say the diameter of that one is 25 millimeter, 0.25 meters, and this one here is also so 0.25 meters. So you'll see here that they're both the same. This one will weigh 3 times as much as that one because it has 3 times more parts packed in. So it's like kind of how compressed items are. So let's have an example of how we can calculate density. So density, if you open up this book here, this is the Engineering Studies data book. Doesn't matter if it's ATAR or general. If you go to page 5, it shows you different densities of items. So structural steel, for every cubic meter, so that means for 1 cubic meter of steel, it would weigh 7,850 kilograms. Okay, you look down at aluminium, it weighs 2,710. So it's a little less than half as much. So maybe a third is 1/3 the weight. You look at brass is very heavy. Solder is very heavy. Concrete's very light. Okay, you go down to plastics. Plastics are very light, all the way down to, it's quite surprising, water, 1,000 kilograms per cubic meter. So water is actually lighter than plastic. That's quite interesting. So let's have a look at how you calculate density. So if you weren't sure to calculate density, if you look on this page here, density is equal to the mass divided by the volume. So let's do a couple examples. And density looks like the letter P. Alright, so you have density is equal to mass over the volume. Okay, and it's also known, so these 3 dots mean also or therefore. So density is equal to mass over volume. Now let's go down, let's look at the units before we move on. Okay, so density, the units for that is kilograms per meter cubed is equal to mass, so mass is in kilograms, and volume is in meters cubed. Okay, now you need to make sure you convert all your weights to kilograms and all your volumes to cubic meters. So you can do that in 2 methods before we get any further. So let's say that we had a square top. So a square box. And this box here was 100 millimeters wide by 100 millimeters long, and let's say that it's 50 millimeters deep. Okay, so we need to convert that to meters before we can move on to this equation. So whenever you have millimeters, you take whatever millimeters you have and you move the decimal spot 3 places to the left. So here's an example. 50 millimeters into meters, we go 1, 2, 3. So now we have 50 millimeters is equal to 0.05 meters. Okay, let's try the 100. So you have 100 millimeters, 2 meters. I need to move it 3 places to the left. So here's my decimal place, 1, 2, 3. So we have 100 millimeters is equal to 0.1 meters. Alright, let's look now at how we will work from here. So if I convert all these three, you'll find that this is the same as 0.05 meters, 0.1 meters. Okay, so now let's calculate our volume. So volume is equal to length times width times height, and that's for a cube. Okay, so length is 0.1 meters times the width times the height. Alright, and let's calculate that. So we get 0.1 times 0.1 times 0.05. So our volume is 0.0005 meters cubed. Alrighty, now have a look. We now have volume of this box. Okay. Now this box is made from aluminium. So let's check our list here. Okay, aluminium density is 2,710 kilograms per cubic meter. Okay, so we got density is equal to 2,710 kilograms per cubic meter. So we want to know how much will this weigh. Okay, so let's put in our equation. We have density, which is P, is equal to mass over volume. So we want mass. We need to find out mass. How are we going to find mass? Mass is on this side, and we've got something beneath it. So whenever you have something on the bottom of a fraction, you can multiply it, you can flip it, and put it on the other side of the equation. So let's look at how that will work. So we're going to multiply that by V over 1, and you must do it to both sides. So you find that this cancels out. Okay, so now you get, so our new equation is mass is equal to volume times the density over 1, which is just equal to the volume times the density. Alright, let's plug in our equation now. So our mass of our box is equal to the volume. So our volume was right here 0.0005 cubic meters times the density, and density is 2,710 kilograms per meter cubed. Okay, so we'll plug that in. 0.005 times 2710. So we get 1.355, and you might want to know what unit that's in. So let's have a look. We have meters cubed on the top and meters cubed on the bottom. See, those cancel out, and you're left with kilograms. So this block weighs 1.355 kilograms.